sklearnmetricsdaviesbouldinscore. Description: the Davies-Bouldinscore is a metric for evaluating the quality of a clustering. It is defined as the ratio of within-cluster distances to between-cluster distances. A lower Davies-Bouldinscore indicates better clustering, where clusters are well separated and internally cohesive. Inputs: X, an array-like object of shape n samples. N features, representing the data points to be clustered. Each row represents a single data point. Labels, an array-like object of shape n samples, representing the cluster labels assigned to each data point. Outputs: score, a single float value representing the Davies-Bouldinscore. A lower score indicates better clustering. Steps: calculate the within-cluster distances for each cluster. This is the average distance between each data point in a cluster and the cluster centroid. Calculate the between-cluster distances for each pair of clusters. This is the distance between the centroids of two clusters. For each cluster, calculate the ratio of the within-cluster distance to the minimum between-cluster distance to other clusters. This represents how well separated the cluster is from its nearest neighbors. Compute the average of these ratios across all clusters to obtain the Davies-Bouldinscore. Metrics: the Davies-Bouldinscore itself is the primary metric used to evaluate clustering quality. The score is typically compared to scores obtained from other clustering algorithms on the same dataset. Visualization plots: scatter plots can be used to visualize the clusters, with different colors representing different clusters. Dendrograms can be used to visualize the hierarchical clustering process, providing insights into the structure of the clusters. Fine-tune parameters: none. The Davies-Bouldinscore does not have any tunable parameters. Uncertainty methods: bootstrapping, repeatedly sampling from the original dataset and calculating the Davies-Bouldinscore on each sample. This can help estimate the variability of the score. Cross-validation: splitting the dataset into multiple folds and calculating the Davies-Bouldinscore on different combinations of folds. This helps to assess the stability of the clustering results. Challenges and fixes. Challenge 1: the Davies-Bouldinscore can be sensitive to the choice of distance metric. Sample use case that resulted in challenge 1 when using Euclidean distance. Clusters with similar shapes but different scales might be incorrectly assessed as poorly separated. Fixes to challenge 1: experiment with different distance metrics such as Manhattan distance, cosine similarity, or other metrics relevant to the data domain. Challenge 2: the Davies-Bouldinscore can be biased towards clusters with fewer data points. Sample use case that resulted in challenge 2: small clusters might have a lower within-cluster distance and a higher between-cluster distance, leading to a lower Davies-Bouldinscore, even if they are not well separated. Fixes to challenge 2: consider using other clustering metrics like silhouette score or Kalinski-Harabaugh score, which are less sensitive to the size of clusters.